So hello and welcome back. In this video we have this example of exponential decay that we will do in this video. So the question is, suppose a radioactive substance decays at the rate of 3.5%. 3.5% per hour. So decays at the rate of 3.5% per hour. So what percentage of the substance is left after 6 hours? So here are a few things that you need to pay attention to. First, we're talking about decay, and the decay rate is 3.5% per hour. Now you want to know what percentage. It's not about the amount, it's about the percentage. What percentage of the substance is left after 6 hours? So, assuming that you have understood the whole problem, it's not about the amount, for example, decayed, it's about the amount left as a result of the amount decayed. And so there are many ways that you can solve this problem, but I guess the most straightforward way is to form a table, because this way we can understand what we are doing. So I have to create a couple of variables, for example t, the unit of which would be hour here. And then I need a function. So let's call it, for example, r, a function of t. This is basically the amount of substance, or the percentage of, so this is the percentage of the substance remained, basically left after t hours. So if you know what you are, basically if you understand what your function represents and what your variables represents and what your units are, for example here the unit is just a percentage. It's no gram, no kilogram, no nothing like that, just a percentage of the substance. And so, but you need to understand what you are doing with these variables. If you understand it, then you can do it. Otherwise, you will make logical mistakes. So here we have a radioactive substance decays at a rate of 3.5% per hour. So decaying at the rate of 3.5% per hour means that at hour 0, when t is equal to 0, no time has passed, you have 100% of the radioactive substance left. So this is, remember that this is a percentage. So basically the output of this function is basically a percentage. Whatever the output is, then you put a percentage sign in front of it, and that basically means that way you should interpret the output of the function. So after 0 hours you have 100% left, because after 0 hours no decay has taken place. And then after 1 hour, because here I have 3.5% decay per hour, so after 1 hour, here I'm adding 1 to the input, I have 3.5% decay. So 3.5% decay means that or basically what I want to find out is how much is left. So you can suppose that you have X amount of something, and then some amount is taken away from it as a result of that decay, and then some amount is left. So basically X minus and the decay rate is 3.5%, so X times 3.5 divided by 100. So that's basically the meaning of 3.5% decay and the amount remaining as a result of that decay. So then you need to basically simplify this. So X into 1 minus 3.5 divided by 100. I've just taken an X out. So then you can simply rewrite this as, X times X into 1 minus, no, sorry. So you can write 1 as 100 by 100 minus 3.5 by 100, so that you can simplify all this. Now 100 minus 3.5 is 96.5, so it's X times 96.5 over 100. And 96.5 over 100, you just need to move this decimal point 2 places to the left, so it becomes 0.965. So X times 0.965. And that is basically, if you multiply 0.965 into any amount, into any X, whatever you get is the amount remaining after 3.5% decaying. So that's the meaning of this 0.965. I repeat that. So that basically what we have found here means that if you multiply 0.965 into any X, any amount, whatever that might be, whatever you get as a result of this, call it A, whatever you get is the amount remaining as a result of 3.5% of that substance decaying. So I can do the same thing here. I can rewrite this as 100 times 0.965. So now I can erase all this. So I'm not memorizing anything, and even if I were to do this whole calculation in my head, I might most probably make a mistake. So I just don't do that. And of course, it's not that I don't want to memorize anything. I cannot memorize anything, because it's a lot of material that then you would have to keep in your head for no good reason at all. So whatever the problem is, if you can understand it, you can find some way to solve it using the basics of mathematics that you know. And the basics of mathematics you don't have to memorize. It's basic simple logic. So again, after 2 hours, after another hour, you have again the same thing happens. So 3.5% is decaying, because the decay rate is 3.5% per hour. So again, after 1 hour, 3.5% is decaying. That means again I have to multiply this whole thing by 0.965. So it's 100 times 0.965 times 0.965. So you can see that now this is 100 times 0.965 raised to the second power. raised to the second power, which corresponds to this 2 here. And this is raised to the first power corresponding to this 1 here. And this is raised to the 0th power here. You don't see it, but you can imagine that it's there, raised to the 0th power. So after n hours, you have the amount left is 100 times 0.965 raised to the nth power. And that is basically your r of t, which this output is going to be, of course, in percentage. So after 6 hours, you can now calculate this. After 6 hours, if t is equal to 6, you have r of 6 is equal to 100 times 0.965 raised to the 6th power. And basically, you can calculate this, and let me calculate it. And this is basically equal to, according to my calculator, it's equal to, or approximately equal to 80.75%. So that basically means that after 6 hours, if your radioactive substance is decaying at the rate of 3.5% per hour, then the percentage of the substance left after 6 hours is 80.75%. Now, whatever the amount of the radioactive substance that you have, or that you had, let's say it's 100 grams. 100 grams you already had, and then you want to know how much of that is going to remain after 6 hours, for example. Then you can simply multiply this 100, or let me do something else. Let me basically not write it in 100, because 100, then again you might confuse it with the percentage sign. So let's say you have 85 grams, and then you wait for 6 hours, and you want to know in advance how much of that 85 grams is going to remain after 6 hours. And based on this, that after 6 hours, 80.75% of that 85 grams is going to remain. So then you simply multiply 85 times 80.75%, and whatever that might be, I do not know. 85 times 80.75% is 68, approximately, or equal to 68.6375 grams remaining after 6 hours of the 85 grams. So that's basically how you could solve this problem. There are other ways. For example, you can see that, for example, here we did a table, and then based on the table we came up with this formula. This is always easier, and this way you can always avoid making mistakes. But if you are more experienced with exponential functions, you could, based on the problem itself, after reading the problem and understanding it, you can directly write this equation, and then do the rest of it, just skipping doing the table. So that's it. That's this problem. We have some other interesting problems that we can do in the next videos. Thank you.